Hi, I'm Chelsea, and today I'm going to demonstrate how we can use integration by parts to integrate a particularly complex function. Okay, so to begin, let's look at the definition of using integration by parts. So, if we have an integral, okay, and the integrand is defined by u times v prime, okay, then what we can do is using integration by parts, it'll be equal to uv, and again u and v are just functions which are differentiable by the variable x. So it'll be uv minus the integral of u prime v dx. Okay? Now right now this probably seems a little abstract, so the best way to learn how to do this is by example. Okay? So the example I chose is the integral of x, natural log of x, dx. And what we're going to do in using this technique is we're going to choose our u, our function u, and then from our function u we'll have our v prime, and then we'll find all the other pieces to our puzzle, which include v and u prime. Okay? And typically when you do use integration by parts, what you have is a function where you can't use u substitution, which if you recall is where we're only defining u, no v's involved. And usually when that happens is you have two different functions. So in here we have two completely different functions. We have an algebraic function x and a logarithmic function, natural log of x, which are being multiplied to make our integrand. So to choose u, you fortunately don't have to randomly just choose u and then see if it works. There's a little rule that I like to remember, and it's the Liat rule, so L-I-A-T-E. And these go in order of which you choose to be your u. So, if in our integrand we have a log function, I'll choose that. If there's not that, then I look for an inverse trig function. If there's not that, then I'll choose the algebraic expression part of it. If there's not that, then we move on to our trig. And finally, if there's not that, then we would use the exponential. Typically, if you're getting down to this point, perhaps integration by parts is not going to be the best solution, but you definitely, if you have a log or an inverse trig, it usually is probably the best technique to do the integration. So if we look at our example, in this case we do have a natural log function, which is nice. So I'll choose that to be my u. And I'm just going to set up the rest here with my v prime, and my u prime. Okay, so my v prime, I chose my u. My v prime is everything else in the integrand that's left over. Okay, and if I choose it correctly, everything will fall into place. To find my u prime, I just take the derivative of my u. So the derivative of u with respect to x is 1 over x. Okay. Now v is the antiderivative of v prime. So basically I can think of it as just an integral. Okay, I'm finding the antiderivative of x. Now you don't want to add any constants, any c's, anything like that. Okay, so the antiderivative of x is just x squared over 2. Again, that reverse power rule idea. Now that we have all 4 pieces to the puzzle, we're ready to put it into our integration by parts. So we'll get our integral is equal to u times v, which is natural log of x, times x squared over 2, minus the integral of u prime, 1 over x, times v, x squared over 2 dx. Okay? Now nothing happens to this first part. Okay. This integrand, as you notice, actually simplifies. This x cancels out, we're left with 1, so it's going to be 1/2 x, and I can bring the 1/2 out in front, so I'll get a 1/2. And then the antiderivative of x is x squared over 2. Okay? Now, once we take this integral and we do this integral, and we don't have any more integration left over, okay? We do, because it's indefinite and the original was indefinite, have to add that c. Right? Sometimes, and not in this example, but when you use integration by parts, you may have to use it another time or even a fourth time, okay? And there's some examples where it becomes reiteration and you end up back at the beginning. You don't want to add this c until the very, very end, until once you integrate this final part, you have no integrals left over, okay? And then once we get this point, we've done the calculus, and I'm just going to simplify. So I'm just going to bring this out in front, x squared over 2, natural log of x, minus x squared over 4, plus c. And there is your answer. As I said, sometimes you really need to use this twice or 3 times, and you just want to keep going. If you pick the wrong u, you may get to, what will probably happen is your v prime will not be an easy antiderivative. If it's more complicated, had we chosen, say, u to be x, we would have had to find the antiderivative of natural log of x, and that is a little more complicated than x. So that is why these rules, it's important to follow and use them and not just randomly pick your u, because it can save you a lot of time and trouble. And that's it. For more information, please visit our website at www.sandersonTestPrep.com. The link is in the description box below. Thank you.